This is the thing. It's definitely not my research. Fucking pop-ups. New force of nature. Scientists close in on a fifth force.
Oh, yeah.
So what is this? They discover mysterious subatomic particles disobeying the laws of physics.
I just want to look at your face when you get incredibly let down. Okay, here we go.
Yes, let me down.
So when we talk about forces of nature, so there's four main forces of nature: gravity that we're familiar with, right? And then there's the electric force, and then there's the magnetic force, and then there's two types of nuclear force. One is called the weak nuclear force, that's like radioactive decay, and then there's a strong nuclear force that's responsible for things like fusion and so forth. When we look at these particles, we say for each type of force, there's a corresponding object that responds to that force. Say it could be mass, like matter, like we're made up of, and there's a boson, and the boson communicates the force to that massive object. So the Higgs boson is what gives particles mass, and that's the mechanism by which we acquire mass and inertia, resistance to motion. Electricity and magnetism, they're communicated by a boson called the photon. The photon is the gauge carrying force that propagates the interaction between magnetic fields, electric fields, charges. And then there's strong and weak nuclear forces. We don't have to get into those. This is saying that there seems to be a new calculation, a new data that's been discovered in what are called muons. And these muons have a relationship between their charge and their spin. And that charge-spin relationship, for one reason or another, should be exactly in a ratio of 2. So their spin versus their magnetic type of property to their spin. And so this little dreidel, one of your last pieces of gifts here. So there it goes there. Not a dreidel. It's a top. See how long you can get that to spin for. Okay, so what they're showing is that, so see that thing is not only spinning on its axis, but the axis is moving around, Joe?
Yes.
That's called precession. That precession for a muon, you can think of as a little tiny spinning top also, and that will have a special relationship between its magnetic properties as it's spinning to its physical angular momentum, which is what this thing is doing.
It's like the precession of the equinoxes.
Exactly wrong. No, it's yes, I think you're right. Yeah.
Still going.
No, it's true. Yeah. Okay, and now I'm going to do something else for you. Okay, so you got that to spin for like, I will give you $100,000 if you can get this thing to spin in both directions over 20 times.
This thing?
This thing. That's all I want you to do. So
what is
each
this?
direction.
What is this thing?
It doesn't matter what it is, Joe. I found it in a crashed UFO.
20 times. No.
No, that didn't count. You can keep trying. I'll give you as many tries as you want. Okay, that's 1, 2, 3, 4, 5, 6, 7. Now do the other way. Try it again.
What's the best way to do it?
I'm not going to tell you. I'm not going to give you $100,000.
I'm just trying to.
I don't have Spotify money. That was the original way you did it. Now do it the other way.
Okay.
Do it counterclockwise.
I'm getting better at it.
Can't do it.
Why is that?
Look at it. Is it symmetrical? Isn't that cool? That's just a simple. There's nothing crazy about it. It's called a rattleback. That thing has symmetry about more than one axis, and such that when you spin it in the direction clockwise, it'll spin forever, like the dreidel. But if you try to spin it the other way, it stops and goes back because there's torque
but
being.
That is the other way.
Wait,
that's counterclockwise.
That's the first way. Now do it.
That's
the other
counterclockwise.
Way. Well, okay, stop.
I think
do it the other way. See?
Interesting.
Yeah, isn't that cool? But to the ordinary eye, if I just showed you this, stops and goes the other direction.
Yeah.
So muons will have this property that they don't have this exact relationship that's predicted by theory. Again, this is what scientists do. They have a model for how nature should behave. We make observations. Now those observations disagree at a very significant level, such that the odds of it occurring by fluke chance is about 1 in 30 million or something like that. And so now they're saying the one way to explain it is if there's another type of boson, which would mean another type of force, which would be the fifth force for those keeping score at home. So that's all that means. It doesn't mean that there's like a wormhole and that they're communicating through it. There are theories like that, but not for the muon experiment.
Okay.